Hi, Algebra 1 students. So what we're going to be doing on this second, or I guess it's really the third and fourth step, we're going to be trying to practice completing the square so that we can get our function into vertex form. The first thing that you'll end up having to do, you kind of learned yesterday, is factor out a greatest common factor. And then after that, you're going to be trying to complete the square at that point. Okay, and what does it mean to complete the square? Well, we have right here on this example, we'll come back to this question later when we complete the square, but for number 5, it says rewrite each trinomial as a perfect square. So these are perfect square trinomials, okay? A trinomial can be a perfect square if you look on here, the first and the third terms are perfect squares. So you have here the square root of x squared is x, okay? So if I take the square root of that, I get x. If I take the square root of 25, I get 5. Those are perfect squares, the first and the third terms. So if you have that case and the middle term is 2, either 2 or negative 2 times, in this case it's negative 2 times the product of the square root of the first and third term. So if we take those answers we just got, 5 and x, and we multiply them together, that's 5x. And then double that basically, that's 10x. And you can see right here in the middle, we have a 10x, okay? And so it can either be a plus or a minus in the middle. But we can see that this is a perfect square trinomial. So what they want us to do is write it as a perfect square. So what we do is we, again, take the square root of the first term, that's x, take the square root of the third term, that's 5. So you're going to put these in parentheses, an x and a 5, separate them a little bit, and then just look at the sign in the middle. In this case we have a negative 10x, so that tells me that I'm going to end up putting a minus sign in between the x and the 5, and I'm going to square this whole thing. So that's rewritten right there, x minus 5 squared. That's rewritten in perfect square form. If I were to multiply this back out, and I'll kind of show you what I mean by that, this is equivalent to x minus 5 times x minus 5. That squared term just tells me I can write it twice. If I were to use FOIL, and I don't know if you guys remember FOIL or if you've learned it yet, but if you do first term times first term, basically distributing, okay? But you do first term times first term, so that's x times x, okay? I'm going to draw a little arrow to that. So first times first term is x times x, which is x squared. Then the outside terms would be the x times the 5, the negative 5 really, okay? That's a minus 5x. I'm multiplying these together. Inside would be taking these two inside terms and multiplying them together. So negative 5 times x is another negative 5x. And then last means take the last two terms in these parentheses and multiply them together. Negative 5 times negative 5 is positive 25. So you can see if I FOIL this, that's what that's called, I end up with this right here. Negative 5x and another negative 5x make negative 10x. So this all simplifies back to x squared minus 10x plus 25, which is what we had in the original question here. So all you have to do, though, you don't have to do all this, the FOIL, I just wanted to show you that, but you just have to rewrite it in this form. So what you're going to do, I'll do another example. X minus 5 squared is the answer for this one. Okay, so let's look at this one over here, the second one. Again, take the square root of the first term. The square root of x squared is x. Take the square root of the last term. Square root of 49 is 7. And then put those together in parentheses. So an x and a 7, leave a little space. Look at the sign in the middle of this perfect square trinomial. It's a plus sign, so we're going to put a plus sign and then just square the whole thing. Okay, so you'll do that 2 more times. So that's rewriting it as a perfect square, rewriting it so that you can kind of see how the vertex form is rewritten. But that's what we're trying to create when we complete the square. So let's go over that. So down to this example. We're going to try to complete the square and rewrite it in vertex form, again, so that we can see what the minimum or maximum will be for this function. So what you want to do is you want to just look at the first 2 terms. Those are the important ones when completing the square. So that's the squared term and the x term. So look at those. And then those are the 2 numbers, or the 2 terms, I mean, that you're going to use to complete the square. So how to complete the square. You'll look at the middle number, which is 8 in this case. You take half of that value. Okay, so 8 divided by 2, and that's 4. And then you end up squaring that number. 4 squared, 4 times 4 is 16. So I just found the number that will complete the square, that will make this expression a perfect square trinomial. So I'm going to put that 16 right there in that first blank. Okay? But what I've done is I've added 16 now to this equation. I myself have added this. So I can't leave it like that because that would create a totally different quadratic. I have to adjust for what I just did on the outside of this. So since I added something on the inside of the set of parentheses, in order to not change the value of the quadratic, I have to also subtract it over here. Okay, so if I put the same number that I added over here and I subtract it, just think about that. 16, if I add a 16 and then I subtract a 16, that's going to be equal to 0. So that's good. I haven't changed the value of the quadratic if I do that. So that's really important to do. When you complete the square and you add something, you also need to subtract it. So that answers this question up here. When completing the square, why do you add and subtract the same number from the same side? Well, you want to make sure that you don't change the value of the quadratic. So you add and subtract the same number so that you get a 0 overall between those 2 numbers. So that's what you want to write down there. So back down to this. We're going to practice again. Now that we have our perfect square trinomial, practice rewriting it like we did before as a perfect square. And all we have to do is, again, they've already done the square root of this is x. The square root of 16 is our number that we got before when we took the middle number divided by 2. It's a 4. Square root of 16 is 4. So I'm going to put that 4 in that blank right there. And then all I have to do from this point is simplify the outside. 14 minus 16 is negative 2. So that's why they have a minus sign there. I'm just going to put a 2 right there. And now going back to yesterday's assignment, now I can see the vertex. So you can see here H, right, goes with this right here, and then the K goes with this one. So if I rewrite this like I did yesterday with a minus so that I can kind of see the vertex a little more clearly, if I rewrote this, I'd have to say x minus negative 4 squared. And then I could also do, if you want, I can either leave it as minus 2, just so I can, see the k value, or I can say plus, if you like that form, plus negative 2. And that way you can really see the k value. So on here, again, the vertex will be negative 4, that's the h. And then here's k, which is -2. So -4, -2. Okay, so you're going to do a couple of examples like that. If you graph the original equation, this one back here, and then you graph this equation right here, you should be able to see that they are the same. And that's why it's so important to remember to add and subtract the same value, because you don't want to change the value of the vertex. So that's why they're just kind of having you over here. If they say graph the original equation and graph your answer, the vertex form, you'll see that those are the same quadratic. Okay, we'll do one more. I'll do one that does not have the blanks already there for you. Okay, so for this one right here, we're going to do number 8. Okay, so for number 8, we'll rewrite it kind of like they did here. So step 1. So you'll want to rewrite it. Again, think about just the first two terms, x squared and a plus 8x. Those are going to be what's inside the parentheses. Okay, and then you'll say plus blank. All right, outside we'll have our -10, or +10 I should say, so plus 10. And then again, put an extra blank outside, because whatever I add in here to make a perfect square trinomial, I need to subtract it out here. So that's why I'm going to put a minus and a blank out there. Okay, so let's do that, and then we'll be able to continue on to step 2. So again, take this number, it's going to be the same as before, but take half of the middle number. The middle number is +8. So take half of that. That's a 4. Square that number. 4 squared is 16. That's the number that gets added and the number that gets subtracted. Okay? And then again, we're going to rewrite this as a perfect square. So again, take the square root of the first term, x squared. Square rooted is just x, because x times x is x squared. And then again, the square root of 16 is a +4, so we say +4, and that's squared. Okay? And then we're going to try to figure out what the number is out here. 10 minus 16, that's a -6. So that right there is the vertex form of this equation. And then we just have to identify h and k. So again, h, whenever it's a plus on the inside, you know that the h is actually negative. So h is going to be a -4. And again, this was a plus k, so I know k is negative. So k is equal to -6. I'm just going to rewrite that up here. So -4, -6, there's my vertex. And again, you can graph this function right here and the original one to make sure that they're the same, okay?